Cinder cone. Cinder cone volcanoes are the simplest and most common type, built from explosive but short-lived eruptions from a single vent. Imagine a fountain of fiery, gas-charged lava blasting into the sky, breaking apart into bubbly pebble-sized fragments called cinders. These cinders cool as they fly through the air and fall back to Earth, piling up around the vent to create a steep, symmetrical cone with a bowl-shaped crater at the top. While they look like the classic volcano shape, they are relatively small, often forming on the flanks of larger volcanoes. Their entire life is usually brief. A cinder cone might erupt for only a few years and then never again. A perfect example is Paricutin in Mexico, a volcano that famously burst from a farmer's cornfield in 1943 and grew to over 1,000 feet tall before quieting forever just 9 years later. Composite volcano. When you picture a classic cone-shaped mountain, you're likely thinking of a composite volcano, also known as a strato volcano. Its steep, symmetrical slopes aren't built from a single material, but are composed of alternating layers of thick, sticky lava flows and explosive deposits of ash, pumice, and rock. This layering occurs because the magma beneath is thick, like cold honey, and rich with trapped gas, preventing an easy escape. Instead of flowing out gently, pressure builds to a critical point, often resulting in a violent, catastrophic eruption that can send enormous ash clouds miles into the sky. These are the powerful volcanoes that created legendary peaks like Mount Fuji in Japan, Mount Rainier in Washington, and Italy's Mount Vesuvius, forming some of the planet's most majestic but dangerous landmarks. Shield volcano. Imagine a mountain so vast and with such gentle slopes that it resembles a warrior's shield laid upon the ground. This is a shield volcano, a colossal structure built not by violent explosions, but by the steady accumulation of very fluid, runny lava. Instead of thick magma piling up into a steep cone, its lava flows easily for great distances, spreading out in thin layers that slowly build the volcano outwards. Over countless eruptions across millennia, these layers create some of the largest single mountains on Earth, like Mauna Loa, which forms a huge portion of Hawaii's Big Island. These volcanoes are so immense that the largest one known in our solar system is not on Earth, but is the gargantuan Olympus Mons on Mars, a testament to this slow, persistent, and monumental style of eruption. Lava dome. Imagine squeezing thick, sticky toothpaste out of a tube. Instead of flowing away, it just piles up into a mound. That's essentially a lava dome. These features are formed by highly viscous, silica-rich lava that is too thick and slow-moving to travel far from its volcanic vent. The lava oozes out and accumulates directly over the opening, creating a steep-sided, rounded dome that can grow over months or even years. While their growth can seem calm, these domes are incredibly unstable. The steep sides can collapse without warning, triggering one of the most dangerous volcanic hazards, a fast-moving, superheated avalanche of ash, rock, and gas known as a pyroclastic flow. A prominent example of this is the lava dome that grew inside the crater of Mount St. Helens after its massive 1980 eruption, a constant reminder of the quiet but persistent danger these structures represent. Caldera. Instead of a simple crater at the peak, imagine the entire top of a volcano caving in on itself. This is how a caldera is born. It happens after a colossal eruption drains a vast, shallow magma chamber just beneath the surface. With nothing left to support the weight above, the ground collapses, creating an enormous basin that can be many miles across, far larger than a typical crater. The stunningly deep blue water of Crater Lake in Oregon, for example, fills a caldera left behind by the collapse of Mount Mazama thousands of years ago. On an even grander scale, much of Yellowstone National Park is actually a giant, active caldera from a past super eruption, a landscape still shaped by the immense power that lies beneath. Fissure vent. Instead of a single, towering mountain, imagine the Earth's surface splitting open along a vast, fiery crack. This is a fissure vent, a linear volcanic opening where lava erupts not from a central crater, but all along a fracture that can stretch for miles. These eruptions often create a spectacular sight known as a curtain of fire, with fountains of very fluid, runny lava jetting into the air. Because this lava flows so easily, it doesn't pile up to build a steep cone. Instead, it floods the landscape, creating immense, nearly flat plains of solid rock called lava fields, or flood basalts. Modern examples of this are common in Iceland, where the land is actively being torn apart. But ancient fissure events were powerful enough to cover areas the size of a country, fundamentally reshaping the surface of our planet. Submarine volcano. Beneath the ocean's surface, a hidden world of volcanic activity is constantly at work, accounting for the vast majority of the Earth's eruptions. When these submarine volcanoes erupt in the deep ocean, the immense water pressure prevents explosive blasts. Instead, lava oozes onto the seafloor and cools almost instantly, forming rounded, pillow-like shapes aptly named pillow lava, which steadily builds new oceanic crust. However, if a submarine volcano grows tall enough to near the surface, the reduced pressure allows water to flash into steam, triggering violent explosions that can breach the waves. Over millennia, repeated eruptions can build these underwater mountains higher and higher until they emerge from the sea to create new islands, exactly how the entire Hawaiian island chain was born from the ocean floor.